Have you ever thought of what happens behind clicking your one single button or on Swiggy or Zomato, like, or maybe place an order for something? Can you think of all the possibilities with your one action? And how does the background handles all these things? So when you place an order on Swiggy or Zomato, there are so many possibilities which can happen with just one of your click. The restaurant is needing this particular thing for starting to cook. The delivery partner gets this same thing because it needs to assign a delivery guy, right? Payments need to confirm your invoice and make your invoices. Your phone gets a notification after some particular time. Analytics, the whole data, KPIs, and all that. And then the inventory, it obviously needs to update their stock, right? So, as you can see, one order can trigger many different systems here. What can you think of this architecture? Like, you can see here, let's say we just put every load on backend server, like the restaurant is getting triggered, the delivery partner, the payment, the notification, analytics, inventory. Everything has a direct connection with your backend. Now, the issue here is, yeah, this can work for a small application. So the orders are not like that one at a particular time. There are like thousands or millions of requests. Imagine you add five more multiples here, like let's say fraud detection, some loyalty kind of points, maybe some customer support, and all these things on just one backend server. Can you imagine that kind of load which the backend server will be handling? Now imagine in the same pattern, all your orders are getting placed one by one in an event stream. Like your backend server publishes it only once, and every system that is listening to it gets that same order and all the event related data from this. Now the overall load from backend goes to the event stream. The event stream is taking care of restaurant, delivery partner, payments, notification, analytics, and inventory. The backend has no load on it. Once the backend transfers it to the event stream, it does not even have to take care whether someone has received it or not. Now, the event stream you see here is actually nothing but just Apache Kafka. So, backend server goes to Apache, publish it once, and forgets it. Now, all the consumers who are receiving the same event can independently receive it. And then Kafka handles all the problems like delivering it to restaurant, delivering it payments, notification, analytics, inventory, everything. Now let's deep dive into the terminologies which are used in Kafka. So producer. So basically you, when you try to place an order on your phone, as you can see, a producer is any application that publishes event to a Kafka. Now, what is a message? A message is just a single piece of data. Now, as you can see here, order ID 1234, your burger combo item, customer name Rahul, and the status is placed. And message is basically nothing but a single piece of data. What is a topic? Topic is a stream where similar messages are stored. Let's say there are three type of topics. One topic is about orders, one topic is about payments, one topic is about users. As you can see, order has similar type of events, payment has similar type of events, and user has similar type of events. But what is the need here to just organize these things? Like, it is very obvious, right? If you mix up all these things, how will the consumer know what they want? If order, payments, and user all are mixed, then what is the sense of grouping them? Each individual stream here has their purpose. Orders, payments, users. Everything has their own roles, and you can define this. This is what Kafka gives you. Let's understand how consumers reads the message. The problem of having one backend and each of the strings getting connected, each consumer connecting to the same backend, the problem has been solved here because on the consumer side, whatever you need has its own topic, and each consumer can ask for a certain detail what they want based on what they want, what kind of service they're offering. Like here, restaurant wants to cook, so they need the order and their details. Similarly, the same order details are also needed by the delivery guy because the delivery service needs to assign a rider. Now, when the order gets completed, you also get a notification. this notification service also needs a order ID. And same goes for analytics service. But analytics service also needs your payment details. So now you have understood what is the role of producer, what is the role of like Kafka, basically the broker, and what is the role of consumer. Now let's understand what is consumer groups. Let's say Swiggy, you can imagine how many orders are placed at a particular minute through Swiggy or Zomato. Now, if you imagine that when so many orders comes, one chef won't be making the all the orders, right? Again, we are assuming everything hypothetically here. So the backend divides it into consumer groups. So chef 1 is assigned 2 orders, chef 2 is assigned 2 different orders, and chef 3 is also assigned 2 different orders. So now all three can process these things parallelly. In this way, the workload gets shared between three chefs and the process becomes much faster and smoother. As I said, why do we need it? When so many orders comes, one chef won't be able to handle it and the queue will be so long that the customer starts to get frustrated. Again, you have to keep imagining how a backend is going to be replaced from the chef or the like the whole example here. So this is the reason why we need consumer groups. Another terms comes as partition. Imagine dividing your topic now. Earlier, we divided different categories like orders, payments, and user details. Now, in one particular topic, we are also making partitions. Why we are doing this? Same reason. To distribute it to maximum number of chefs and decrease the load, as well as reduce the time of processing it. So now orders topic has three different partitions and one partition is being handled by one chef. So each chef handles one particular partition. So now what happens is this reduces the load on the chef side. So here the consumer can process things in much organized way as well as faster way. So now the most amazing thing about Kafka. Let's say whatever your consumer was, whatever service it was, goes down for some reason. For our example, let's say our chef got a call. So he is engaged at some other place and he is not there. Now the last order he did was till 1234. Right? The last order ID was 1234. What Kafka gives is an offset. This is a position of message which tells you where was the last index I was processing. We can add it before the processing and we can also choose to add it after the processing. That depends on the code. What happens here is when let's say the chef comes back, he knows the last order what he did. So he continues from there. So if our machine goes down, whenever it wakes up for whatever reason it crashes, it can restart from that particular point and Kafka gives you that particular position. As I said, no need to start over. So in a particular partition, it should not be like that even the orders which were processed are processed again. So it does not make any sense, right? So Kafka stores a last offset for every partition. Now here comes the heart of Kafka, which is Kafka broker. Now we have talked about producer, we have talked about topics, we have talked about consumers, we have talked about partitions, we have talked about everything. But where are all these things getting stored? So this is where Kafka brokers comes in. Kafka broker stores everything, whatever we had discussed, the topic, the partition, the messages for producer and as well as consumers. Now you will ask me, Suraj, why do we even need Kafka broker? What are we even going to do with this storing of messages? Let's say your analytics service needs to read this old event, something happened in your system and you need to read it. And if that particular thing is in between the retention period, so there's something called retention period. So that is the time until your Kafka broker stores all these details, whatever we had discussed before. So this can be reread at a particular time in future. So whenever let's say your chef has taken the order, he can replay the order, the old orders, whatever he has delivered, or this is like in a way, if you think on the chef side, he can have a track of all those orders which he has delivered. Now, let's try to put everything what we have discussed in one particular slide. your producer, your Swiggy's or Zomato's backend, who once you tap on that button of placing the order, your Kafka broker through your backend gets all these topics divided. Let's say the order is the topic. Now, in this topic, you divide it into multiple partition based on the frequency of orders you are getting, right? That depends on your code. Now, each partition has an offset. The offset, how it can help? It helps whenever a system service goes down and it needs the point until where it has read, right? Now, consumers each can read independent datas from partitions. Consumers can also be divided into groups. Each group can have its own read. And because every service reads here independently, you can scale this to millions of users and millions of requests. And this is the reason why companies like Uber, Swiggy, Zomato, and so many big orgs uses Kafka to have so much reliable, scalable, and independent event-driven communication, because there are so many services attached to one particular thing, right? One order can trigger multiple services. I hope you have understood the foundations of Kafka. This was just to give you a gist how Kafka is, how it works from like top of the funnel. And if you like this video, please drop a like and a comment. Please give me a feedback so that I can improve. What is the place where I should be focusing more on, and what kind of topics do you want? So also please subscribe to my channel. Thank you for watching.